It's enough. All right. I want to greet you once again. This is GC paper A-level computer science paper 3, June 2022. So advanced level, as I already said. So on this paper, we are going to focus only on the programming part. I always have the habit, or I've always told my students that database is not a problem. Database is not a problem. Even everybody can teach it and the student will understand. The problem is the programming section. Not even everybody understands it. Talk less of teaching it for other people to understand. So I'll try my best so that we can be able to understand this programming section. I have already answered everything under programming. I've already programmed the codes. These are the codes. Everything is already up and running. Since we are having a lot of problems with electricity here and there, and I do not want that we should spend too much time typing the codes. I will better take time explain how the code works, how I was able to type the code and so on, for you to understand. Then when you have time, you go through and you're able to maybe type the codes and implement to see for yourself. Okay, that notwithstanding, programming. You are to design a program to help people in primary school to list all the prime numbers found within a given range of positive integers. A prime number is divisible by 1, only by 1, and itself. However, 1 is not considered prime. Use the following algorithm to gain the desired list of prime numbers. So, generally speaking here, we are told that in task 2, programming, we are going to write a program that is going to help a primary school child to be able to list all the prime numbers that are found within a certain range of numbers that that child will be able to put. And so we are told here, in case you have forgotten, that a prime number is actually a number that can only divide 1 and itself. And that 1 itself is even not a prime number. And it's true because 1 can divide every number. Any number divided by 1 can go. So it's not a prime number. So we are told to use this algorithm. They say use the following algorithm to get the desired list of prime numbers. First, get the maximum value of a range from the user, and then you call it n. Then you fill the array with numbers from 1 to n. And we are told here to take the array size to be 100. The size of array is different from the value n, take note. Starting from the beginning of the array, we should eliminate 1 from the array by setting it to 0, because 1 is not a prime number. Then locate the first prime number. Then after that, we move to the next number in the range to find out whether it's a prime number or not. Then set all its multiples to 0. What does that mean? It means that when we are able to locate a prime number next, the multiples of such a number should be set to 0, except, of course, the number itself. And then move to the next number. That is already a loop. Okay, they are even telling us here that repeat step 4, that's the step 4 I was talking about, that is already a loop, for each new number there. So after we have located the next prime number in a range, after 1, we set the multiple of such a number to 0. Then move to the next number, perhaps 3. If it's a prime number, of course, it's a prime number. We will now set equally the multiples of 3 to 0 until you get to the square root of n. call this square root of n root n. This one is going to be like a variable that we have already been calling in our program. So when they say we should get up to root n, what does that mean? It means, square root of n. It means that if we have our n to be 20, we are going to locate the prime numbers from 1 to 4, because the square root of 20 is around 4 point something. And so they say obtain it via the square root function of your programming language, and then round it up or down to an integer value. It's true, because the square root of 20, which is an integer, will give us a float. I think that I'm talking to computer science students and they understand what floating means as far as data types are concerned. And the number that we are going to be talking about are supposed to be integer values. We don't have floats as prime numbers. We have integer values, among which we have prime. So when we take the square of a number, which is an integer, we may likely land into a floating point. And so we have to use a function which is actually embedded or included in our programming language. And then we either use that function to round up or down that number, that square root number, to have an integer. We are being guided here. Note, rounding may be either through a round function or whatever your programming environment may offer. So you have to master your programming environment to be able to know what your programming environment offers, so that you should be able to round up the number to the nearest whole number, or truncation to an integer value, such as through a typecast. Wow. Here in C programming, it supports this one. And that is what I use in my program. I was able to typecast my floating point so that I can have integer. You will see it when I will reach there, I will tell you. So you have to be careful, keen, and then you follow the program very carefully. So we have integer arithmetic or assignment to integer variables. So they are still explaining about how to get the integer part of this square root of a number. When that is done, we display all the numbers in the array that are different from 0, and they should all be prime numbers. So number 6, we are now going to do what? Display the final result after setting the known prime numbers in a range given to 0. So if we set all of that to 0 at a certain in that range, we are now going to have the remaining numbers, which shall be prime numbers. Good. So this is interpreting the algorithm and interpreting the question for you, saying you said you equally have trouble interpreting questions. Okay, illustration. So this paper was partitioned into 3 sections. The first section was talking about the programming itself, or the task itself. The second section, they are illustrating to us to understand what the task is all about. And then the third section was actually the application of what this paper is all about, or the task is going to do. So here, we illustrate how the algorithm works. How is this algorithm going to work? 1, we are still using the algorithm above. This algorithm, how is it going to work? We are going to obtain or declare an integer, an array called tab, which is going to have a size of 100 or of integers. And you see that here we're told that fill an array with number from 1 to n, then take your array size to be 100. So they are illustrating it. So they are saying that the first thing is that we are going to obtain or declare an array, and that array is going to take the size 100 and will be integer. And then they said, suppose the maximum value of the range given is n equals to 10. So here we have been told that we should suppose, this is just an example, that we take n to be 10, which means that primary school people has entered a value n, which is 10. When that happens, we fill an array tab with n numbers. That's it. We are going to have 1, 2, 3, up to 10 integers in this range. And that's array. Then it says set entry 1, the first to 0. So this 1 is now set to 0. Why? Because 1 is not a prime number. And here in our algorithm, they say starting from the beginning of the array, eliminate the number 1 from the array by setting it to 0. Then locate the next prime number. And then you set all the multiples to 0. Good. So this is a illustration here. It has been set to 0. We need to locate the next prime number, which is 2. Of course, 2 is a prime number because it can divide only 1 and itself. Now, we identify all the prime numbers from 2 to root n and set to zeros their multiples found in the array as follows. This is how we are going to set the multiples of 2 to 0 because they will not be prime numbers. Rounding up the square root of n, that is, of 10 to get 4. And then identify 2 as a prime number. Excluding 2 itself, set to 0 all multiples of 2, right up to n. So the rest of the numbers 4, 6, 8, and 10 to obtain this. What does that mean? It means that after locating the next number on the range is 2, and 2 is a prime number, all the multiples of 2 are set to 0. You see the multiples of 2 we have, after 2 we have 4. 4 is set to 0. Why? Because 4 divided by 2 has no remainder, and 4 again can divide 1 without a remainder. So you see that it is already a number that is dividing more than 2 numbers. But a prime number is a number that can divide only 1 and itself. 4 can divide 1, it can divide 2. So therefore, it's a multiple of 2. We set it to 0. We move to the next one, 5. 5, sorry, we are still on that range. Let me not go to 5 yet. We see that 4 is a multiple of 2. 6 can divide 2. We set it to 0. 8 can divide 2. We set it to 0. 10 can divide 2. We set it to 0. Or it's a multiple of 2. Identify the next prime number, which is 3. Again, excluding 3, we set the multiples to 0. This is 3 now. After 3, we have already set 4. 4 is not even a multiple of 3. Then you see that 6 is a multiple of 3, and we have already set it to 0. 9, you see 9 was here. 9 was here. It was not a multiple of 2. Now it's a multiple of 3. It is set to 0. And so on. That's how we're eliminating the numbers which are not prime numbers in a range given. And then the next available non-zero number is 5. This is a non-zero because the next number is 4, which is already 0, showing that it's not a prime number. And then 5 is a prime number. It's greater than square root of n. You see that the square root of 10, we are supposed to have a value that is below 4. So when you look at it very carefully, you see that 5 is already more than. So we stop. That's what they are telling us. We now display a prime, we display or print all the non-zero numbers of the array are the prime numbers found between 1 and 10. So see, for example, we are going to have 2, 3, 5, and 7, which are only 4 numbers. 1, 2, 3, 4. And that's why we say we are going to have 4 numbers. Application. Here, we develop the required program by following the steps below. Okay, so far, I don't know whether there's a question because we are getting into the application now. There's no question. Okay, that's good. Let us proceed to the first one. In your answer booklet, state the programming language you will use. Then, give a more detailed version of the algorithm above in pseudocode. In your pseudocode, let n be equal to 20. Remember, that's 3 marks. In our program, or in our task, we were given n here to be what? 10. Now, in our application, we are now told to use n to be 20.
20.
So you see that when you want to rate a practical paper in program, you need to read the whole question before you start working on. If you just start working without reading and interpreting, you may end up writing the program and then not following actually what is being asked. And up there was just illustrating. That was just an illustration. And here we really have the questions to apply. Okay. Please, if somebody have put this device in loudspeaker, please try to put it in a normal speaker because the sound that is coming from the background is disturbing. Thank you. Okay. So here we are going to go to our answer booklet. Thank God I already answered this question completely. I want to get to this page. This is where I already put all my answers. I've answered this question paper and documented it for future computer science engineers like you people. So this is a question paper I already answered. I call it mini project 1. So I'm documenting the things because for the past years I've been solving, but I've not been documenting. And each time I need to solve again, it's going to take me a lot of time, which I could just review and then everything is okay. Master Harman, please, your speaker is disturbing. All right, thank you. Okay, so going straight to the question, these are my answers. I say, what do we need to do? That is only for that question. I already interpreted all of this. There's no need to interpret again. Question 1. In your answer booklet, state the programming language you will use. Then, give a more detailed version of the algorithm above in pseudocode. In it, let n equal to 20, 3 marks. I designed this page. I say, okay, this is my answer booklet. Are you seeing? In my answer booklet, this is what students were supposed to write because a past GC question. They were supposed to write programming language to use is C. If you're using C programming language, not so. Because we are asked to use either Pascal or C programming language, it is advisable to use C because we have been studying but C in our class online. So if you don't use C, it means that you were maybe studying another language like Pascal. But since I've been doing classes with you online, we have always been using the C. After teaching you small preliminaries of C or some courses in C, we are able to use C to answer this question. So when you do that, I think they are going to give you a mark. If you identify your programming language already, it means that you know what you're doing. They should actually credit you for that. Then a detailed version of the algorithm in pseudocode. This is actually crazy because you cannot write this kind of algorithm for 2 marks. To me, it's crazy. So, but what should we do? It's already an exam, and we are focused on the understanding and the knowledge and not on the marks as the overall stuff. So here, I beg to reduce my size a bit so that you people can see the whole program at once. Good. So here you have start. Start is a normal culture, a normal principle, a characteristic of an algorithm to always start and end. So I started by starting my program, my algorithm, and my algorithm is in pseudocode and ending. So they were asked to enter an input. I want to interpret this so that you can know whether I'm on the track or not. Input n, that is obtaining that maximum value of a range from the user, right? And we said we should take n to be 20. In our program, they say we should take n to be 20. This is it. Let n be 20. So I say set n to 20. Then now they said create an array called tab of size 100. I think that's what was given in our question. Then for I starting from 0 to n minus 1, we should set that array at that position I to be equal to I plus 1. Now, n4 means that this for loop is ended. We set that first number at that first position or that first index to 0. And that first number is 1. Why? From here, we said our I start from 1. I mean from 0. Which means that in my array tab, the index or the position array of 0 should be equal to I is 0, 0 plus 1 is 1. Which means on our table, we are going to have 1, this is it. And this 1, we set it to 0. Set to 0. That's why in my algorithm, I said, let the array of the first index 0 to be equal to 0. Then set the root n to be equal to the integer part of the square root of n. Because they told us in our program to do typecasting or to make sure that the square root of the
Excuse me,
number,
sir.
yes.
Please increase your voice. There's rain is falling. We're not hearing.
Okay. I'm saying that, can you hear now?
Yes, sir.
I'm saying that here we were told to to make sure that the square root of the number here is equal to, is an integer. That's why I said we should set the square root, and this square root were given in our program to use as a variable. Let me locate it for you. This is here. They said, call this square root n. Okay. And they said we should make sure that we truncate it to have an integer value. So I use in my algorithm, I said set the root n now to be the integer part of the square root of n, not the other part. Good.
The application
Yes.
where we say set tab I equals to I plus 1. I'm understanding that, please.
Okay. Here, I'm saying that you should assign, set means to assign. Okay? It means that we should assign tab. Tab is the name of the array. At that position, which is 0, because array in C programming start from 0. So at position 0 or at the index 0, we should put 1 because I equals to equals to I plus 1 means I itself is already 0 from the loop starting from 0. So 0 plus 1 will be 1. And we are going to set that 1 to be equal to array at that position 1 here. This is 0, 1, 2, 3, 9. So you see the index of this number is 9. Is that clear? So we are setting this 1 to 1. That's why in my array, in my algorithm, I said we are going to run from where? From 0 to n minus 1 because our n is 20. If our n is 20 and we are starting from 0, it means that we are going to exclude 20. We are going to now run from 0 to 19, which will still be 20 because the index of array starts from 0. I hope it's clear now. The person who asked me the question, where is he? Is
Okay.
it clear?
Yes, sir.
Okay. So we also said, which means we assign the first index, which is 0, array of 0 to be equal to 0. This is this one now. We are here. Set entry 1, the first to 0. this one. The algorithm is here. Set the root n to be equal to integer part of the already explained. Now for I from 1 to root n 2, we are now starting from 1. Why? Because we have already said we are already left the first index. We are locating the second number in the range. So we are here. We are already done with this one. We want to set, oh my God, we may not have enough time anyway. We want to set the next number now in the list, which is here, 2. We want to locate the next number in the list, which is 2. And that 2 is at position 1. So we are now moving from 1, no longer from 0. From 1 to root n. Root n. We have our n to be 20. So we're moving up to root n. We do. If the number at that position, which is 2, is different from 0, 2 at this position, after this, you see that it's 2 is different from 0. That's what they are saying. What should we do? I already interpreted this. We said 4. Then for j from I to 1, from I plus 1 to n minus 1, do. What does that mean? It means that j means the next number in the list. The next number, which is different from this number. And they said that number starts from I plus 1, which is start from 2. From 2 because I is 0. From 3 because we have I to be 1. 1 plus 1 is 2. To n minus 1, do. We should take the modulus, that number, mod this number. If it's equal to 0, then it is a multiple of that number. And then we n. And we do the same thing here on the next one and print. Let me go and explain that part. It means that this is my I and this is my j. If I now take the number at position, this number 3, I look at this, I make it to be this number modulus this, which means when I divide this number by 2, if the remainder is 0, therefore it's a multiple of 2. I set the number to 0. That's what this code is talking about here. Here like this. This is what I'm saying. That if the tab of j mod tab of I is equal to 0, which means if I divide this number 3 by 2 and the remainder is 0, it means that it's a multiple of that number. I need to set that number, which is 3j, to 0. Then I move here. For I from 0 to n minus 1, if the number of this position is different from 0, then I should print it. This is printing of the array now. So I need to go and start again from index 0 and then check if the number is different from 0. It's have 2, 3, different from 0. We should now print the array. So that is why I say if the tab of that I is different from 0, then we should print tab of that number. I hope it's clear now. This question. Sorry? Okay, thank you. So that is 3 marks gone. Gone. That's where you're supposed to write. Now we move to the next question. In this thing, I already explained what I was explaining to you up here. This is it, explanation. So I explained it already here, everything. I've already explained everything, what is happening at each stage. Each stage already explained. So there's no need for me to explain again. I explain, maybe one neighbor can tell, somebody can lay hand on this document is sweating. The person will be able to find himself out. So write this question number 2. Write a subprogram called initialize tab n that fills the array tab with number from 1 to n, 4 marks. So what are we expected to do here? We are going to write an array or a program, and we know that a subprogram, as they are talking about here, is a function or procedure. And the name of the function is initialize, which is taking the name of the array tab and then the size of the array n, and then fill those numbers that we saw 1, 2, 3, 4 up to the n. Here, this is it. I say this function fills the array with numbers from 1 to n. So void initialize int tab name int the size. Then I here is a counter to move inside the array. Then for I starting from 0, I'm just converting now the algorithm to programming. And I'm not doing any strange thing anymore. The real work was to be done at level of writing the algorithm. Now the algorithm was written. We are just interpreting the algorithm into programming. So to initialize, to fill the array using this function, we use the for loop starting from 0, and that number is less than n. I already told you why. We increment, and then this is a tab I equals to I plus 1. That is, somebody asked me a question. That is done. And then the third question is we should write a subprogram called verify prime of x. That takes a number x and verify whether it is a prime number or not. For this, x is not divisible by any non-zero number less than it in the array tab. So here, what are we doing? It means that we are going to verify whether the number which is next on the list is a prime number. So, and they say we should take that number as x. Here's a program that I wrote. I now say, okay, for I equals to 2, my I has left 1 to 2, less than the number we are looking for, we increment. And then if the number modulus I, that part that I told you, if the array at this position modulus the array of this position is equal to 0, then it is divisible exactly by I. We set it to 0 because it's not a prime number. But if it does not equal to 0, it means that it's a prime number. So we return 1. So return 0 here means not a prime number. The return 1 here means it is a prime number. I will run the code for you to see. I will send you this file. Don't be afraid. So you have question number 4. Write a program called set 0, which is going to take an array name with a size n, and then that number, we want to check whether it's a prime or not, and then set the multiple to 0. This is a program that I wrote here. Means that at this stage, this is what the students were supposed to write. The same procedure. Then my counter, if the number I'm looking for at that position is different from 0, let me take, for example, 2. 2 is different from 0. And if that 2 divided by the number the user have entered is equal to 0, and the number 2 itself is different from the number the user entered, then we should set that number to 0. Set 0. This is setting the multiples of that number to 0. So the next question was question 5, which is talking about do display tab, which is the name of the array, and then the number. So here we are going to display the elements or the number that are left in the array, which are now arrays, prime numbers. So here is a function to print that, display that number or those elements in the array. Then question 5 now is to combine everything into a main program. So we call the function we just wrote up there into a main program and make sure that our program runs. So this is my final code, and this is my result. This is my result. So because we are told that print your entire program, including its sub-program. So that one is 1 mark just to print the output or everything. I'm interested in the last question. Test your program with n equals to 100. Then you save the output and print it. This time around, I'm just going to go to my code. This is my code. So talking about June 2022. This is my code. I need to include this library because I'm going to use root n, the square root. Then this is macro to define the maximum number in a range. Here, function, declaration, or prototype. So my function prototype. My main function, you can see my codes. Everything is labeled so that you should be able to know what happened at each stage.